Good morning, everyone. So yesterday we discussed about the method overriding concepts here. So we'll try to continue the same example here. So here, so what we did inside this particular method overriding a class here. Inside this particular method overriding a, we define the show method, and here inside this particular method overriding a. So again, I'm defining the same method. Here, the name of the signature and everything is same here. Getting the point. So this is important. We need to understand here. Getting the point. So what exactly we are doing here? Whatever the name of name of the this particular method as well as name of the this particular signature is same, and the same method we are trying to write. We are trying to define inside this particular subclass here. So same way now what happens internally? If I'm going to write this particular method something like, so I will remove this particular show method string here. Now what I want to provide something like message here. Okay, and instead of along with this particular key, now what I will do, I will write message. Okay, and this particular message I'm going to print. Now observe carefully. This show method now it is expecting one parameter. Okay, and whatever the show method we define inside this particular super class, this particular show method is not expecting any parameter. So see the differences here, how exactly it is going to work. Okay, now again, what I'm doing here I'm going to call this particular show method. So whatever the earlier example we implemented, the same example I'm going to use. Now observe carefully what happening internally. This method is calling int values. So whatever the show method I'm calling here, so now tell me this show method is called from the subclass or the superclass show method. Okay, so it is called the superclass method. Getting the point. So why at this time why it is called the superclass method? What we need to understand basically here, first it is giving the priority to this particular subclass. Okay, first it is giving the priority to subclass, but subclass we don't have a method, so which is expecting this particular signature. Okay, this particular signature we don't have. So whenever we don't have this particular signature, now what happening internally, it is looking for the superclass here. So here you can see superclass we define, and here subclass. So here also we are having show method, and it is expecting string as a parameter here. Okay, and whatever the show method we defined here, it is not expecting anything here. Okay, this show method and this particular show methods are different now. So whatever the method we are having, this method we are not overriding into this particular subclass here. So this is important here. Getting the point. This is the specific method we define inside the superclass, and this is the one more specific one more specific method we define inside this particular subclass here. Okay, both are not same method. This is important. Now, what happening here? So we created this particular subclass object. Whenever we are creating this particular subclass object internally, what we are doing is we are trying to getting the point. What we are doing here, we are trying to so give the 100% priority to this particular subclass. But right now, what happening internally, whatever the signature of this particular show method we are defining here, this show method it is no longer available inside this particular subclass. Now, what happening internally? Now it is trying to move on to the superclass method here. Okay, so by seeing this particular message, we can easily understand these informations are coming from the superclass here. Now, if I want to call the subclass method, what is the best way here? If I want to call this particular superclass here, we need to provide the message. So what is the message? Something like a subclass method. Okay, I'm defining subclass method here. Now, observe carefully. K value 96 we are calling, like K value 96 is providing and a message. So what is the message we are providing here? Subclass method. Subclass method. Now this is the specific method. This is the specific method we define inside this particular method overriding B, because it is expecting one parameter here. And the same way, if we observe carefully inside this particular method override class here, so this show method, it is not expecting any parameter. So here what we need to understand, whatever the signature we are defining is, the signature is different from the superclass to this particular subclass here. Okay, so this is very important, we need to understand. Now, so in this case, what we need to understand, these two methods are the override methods. These two methods are the override methods, or it's a specific method which we define inside this particular both classes. Basically, these two are the specific method we define inside the specific class here. Okay, so whenever we are going to write the overriding concept here, it should match the same functionality which we define the superclass and should match inside this particular subclass here. So this is very important, we need to follow here. Okay, then only we are going to override the method. So then only the superclass method is going to hide here. But here the superclass method is not going to hide and the subclass method is also not going to hide, because the methods are different here. Getting the point? Whatever the method we are calling, this method is expecting one parameter and the superclass method is not expecting any parameter. Okay, so this is very important, we need to understand. So any questions?
No, sir.
Okay, now so another important concept I'm going to discuss here, something like dynamic method dispatch here. So this is also one of the important example I'm discussing here. So how this particular dynamic method dispatch is going to work. So to understand this, now what I will do, to understand this particular example, we are going to discuss about these two example, method overriding A and method overriding B, and I'm going to create one more. So one more class I'm going to create here, something like a method overriding C class I'm trying to create. And inside this particular class, so what I'm doing here is expecting two parameter, and here it is expecting three parameters. Okay, so I will copy the entire information and I will paste it inside this particular class. And now what I'm doing here, I am going to extend here, sorry, method overriding here. So see this hierarchy. Now what we need to understand here, we have a one superclass. Okay, now it is extended with two subclasses here. Getting the point? What is a superclass? Something like the method overriding A. Method overriding A is the superclass, and it is extended with method overriding B as well as method overriding C. Getting the point? So right now one superclass and we have two subclass. So this is the different hierarchy. Getting the point? So we'll observe carefully how this particular example is going to work. Now what I'm doing here, I'm trying to define this particular method overriding C, and here we can define the K value. But here this particular K value, what we can do, so here we can write the message. Here I'm going to write the method override C K value. Getting the point? This is important, we need to understand here. Okay, so this is very important, we need to understand here. Now what I'm doing here, so if you observe carefully, okay, we'll try to remove this. Okay, we'll try to focus on the first example. Whatever we define the method overriding concept, now I'm trying to remove this also. Okay, whatever the message we provided the parameter, I'm trying to remove this. Now all the methods are same. Now if you observe carefully, method overriding is contain the show method, method overriding B, it's contain the same show method, it is having the same signature also. Now you can see it is having same signature inside this particular method overriding C. Now what we need to understand, how I'm going to create an object here. How I'm trying to create an object here, this is very important, we need to understand here. So right now, what I'm doing is, I'm trying to create a object of this particular, all the classes. So first I'm going to create a method overriding A and B, and I will create a C object here. Getting the point? So this is important, I'm trying to create here. And the constructor also I'm going to modify to. Okay, this is the method overriding A and method overriding B, and I'm going to identify the method overriding C here. Okay, so this is important, we need to understand here. Now I'm trying to create the three classes. So I will modify the values here, something like here 96 and 85 and 74. And this values also I'm going to modify here, and 65, 32 and 98 here. Okay, now observe carefully. I'm trying to modify this particular values. So what we need to understand carefully here, how many objects I created? 3 objects. So here I'm trying to create a super object, and these 2 subclasses object also I'm creating. Whenever I'm trying to create this particular object, now what we need to understand here, I'm going to provide the one references here. So carefully observe how I'm trying to providing this particular references here. Okay, instead of this particular method overriding A, now I'm declaring this. Get in the point. Here I'm not creating an object. So this is basically declaring an object here. Declaring this particular object. So what is an object I'm trying to declare? Something like method overriding A. Why I'm declaring this particular object only? Because this one is a superclass. Get in the point. Whatever this particular method overrides A we created, this is the superclass. Now, it is this particular class is extended with these 2 classes. Now carefully observe what I am doing here. So once I created this particular method overriding A, now MO is equals to, getting the point. This is important. MO is equals to MOA. Getting the point. MO is equals to MOA. Now whatever the MOA is nothing but this is an object type. So this is a reference variable of this particular object called method overriding A. Now what I am doing here, the whatever the object we created, this MOA, now I'm trying to assigning into this particular MO. Now what happens internally whenever we are trying to assign here? So once we assign this particular MOA into this particular MO, now I'm going to call MO dot show method. So now tell me which show method is going to call here. The line number 22, I'm calling the show method with the help of MO, not MOA. Getting the point. This is important here. Whatever the like method overriding A, the object we created, the same object I'm trying to store into this particular MO, and this particular MO dot show method I'm calling. MO dot show method I'm calling. So which class show method is going to call? Okay, so this is important, we need to understand here. Basically, this particular MO, it is a what type right now. Whatever the MO we created here, it is a what type here. So it is a type of this particular MOA. MO is a type of this particular method override A. Okay, now observe carefully. Whenever I'm trying to call this particular MO.show, I and J values are printing. I and J values printing. Where we define this particular I and J values? So here I am trying to print the I and J values here. Okay, this is important, we need to understand here. So this is, we'll call it as a method overrides A. And finally, what I will do, I'm going to call the MO is equals to MOB. Getting the point. Now again one more object I'm trying to pass. So at this time MO dot, again I'm going to call the show method. So at this time, so which show method is going to call here? Getting the point. At this time which show method it is going to call. The line number 24, whatever the show method I'm calling here, now which show method it is going to call.
Method override B class method is called.
Yes, so this is important, we need to understand. So why it is going to call the B class here. Finally, compile time, line number 24, basically compile time, it is going to look up the method inside this particular method overriding A, but runtime, what happening, it will look up this particular method overriding B. So for example, I'm going to comment, like I'm going to comment out this particular show method. Whenever I'm trying to comment out this, now we are getting an error. So observe carefully. So this show method, because it is called the superclass, now we understand here. But why this is getting an error? The line number 24 also, it is giving me an error because of the superclass method I commented. But observe carefully, even whenever I commented this particular superclass method, but runtime, this method is not going to call. Runtime, this method is not going to call. Okay, so observe carefully. Just I'm giving an explanation. If I comment out, we are getting an error. Now, this error is now resolved here. Now I'm going to run this example. Observe carefully. Okay, sorry, I did not save this example. Let me run this example one more time. Observe carefully. The line number 22 show method, it is called by this, and the line number 24 method, it is called by the k value. But observe carefully, runtime. Get in the pen. This is important. Runtime, the method is whatever the method calling, the path of calling is I changed here. But compile time, it is trying to look up the superclass method, like the method overriding A class method. But runtime, it is move on to the k value, which is printing from this particular method. Here we are not providing any information, just we are printing this particular k value. Okay, whatever the k value we are having 98, the 98 value it is printing. So observe carefully. So it's correct or not? Here only we are providing 98. The same 98 it is printing here. So these two will go to the I and J, and the 98 it will go to the k value. Okay, same way. Now what I'm doing here, MO is equals to MOC. So this is the one more child class object I'm passing here, and finally MO dot the show, the same whatever the show method we are having, the same method I'm going to call here. Okay, now observe carefully. Now the last method you can observe carefully, method override C, the k value it is printing here. So now if I'm going to comment out this again, the show method, all the three methods, whatever the three methods we are having, all the three methods we are going to get an error. Getting the point? So now you can see all the three methods we are getting. Line number 26, 24, and 22. Now what you understand here, compile time, the method is looking in the method overriding A class. Why it is looking in the method overriding A? Because what is the MO type? What is the MO type here we are defining? Something like we are defining method overriding A type here. So because of this particular method overriding A, now what happening internally? Compile time it is looking about the superclass, and runtime it is trying to look up the which object is created. Which object is created. So this particular section we'll call it as a dynamic method dispatch here. So this is very important example we are discussing, because so based on the references, runtime it is the calling of this particular method is changing here. Okay, any questions here?
Sir, if we call directly using a reference variable like MVC dot that show method, what will happen, sir?
So directly it will go to the subclass method. So for example, if I'm trying to call here MOC.show method. Now either if I'm going to comment out this, so whatever the superclass method we are having, now you can see how many methods we are getting error. Only two methods we are getting. Why we are not getting this error? Because object we modified here. MOC compiler, what it will do, it will look up this particular class, and here we are having the type also method override C only. Getting the point? Object we are creating the same object, and the type also we are making the same type. So it will look up the subclass show method. If the subclass show method is no longer available, it will give an error here. But so the method is already existed. Getting the point? But the problem basically Compile time, it is looking the superclass method. Runtime, it is moving on to the subclass object here. So this is the way of calling the methods internally.
Okay.
Okay. Sai, నీకు ఏమైనా క్వశ్చన్స్ ఉన్నాయా?
ఎస్ సార్. సూపర్ క్లాస్లో ఏ మెథడ్ యూజ్ చేస్తారు సార్? ఎలాంటి
Super.
మెథడ్స్ వస్తాయి?
సో అది బేసిక్గా మన రిక్వైర్మెంట్ ప్రకారంగా యూజ్ చేసుకోవచ్చు. ఎలాంటి అయినా అంటే డిఫైన్ చేసుకోవచ్చు. బేసిక్గా ప్రస్తుతానికి మన అండర్స్టాండింగ్ పర్పస్ నేను ఇక్కడ షో అని డిఫైన్ చేశాను. ఓకే. అండ్ ఇప్పుడు నేను ఒక ఎగ్జాంపుల్ చెప్తాను. ఈ ఎగ్జాంపుల్ చూడు. సూపర్ క్లాస్ లిస్ట్. ఓకే, ఇది ఒక సూపర్ క్లాస్ అనుకో. అంటే ఇక్కడ నేను ఇంటర్ఫేస్ అని డిఫైన్ చేశాను, బట్ ఇగ్నోర్ చేయి. ఇది ఒక సూపర్ క్లాస్ అనుకో. ద సూపర్ క్లాస్ నేమ్ లిస్ట్ అని డిఫైన్ చేశాను. నాకు ఇక్కడ ఎన్ని మెథడ్స్ ఉన్నాయి? సైజ్ అనే ఒక మెథడ్ ఉంది, ఎంటీ అనే ఒక మెథడ్ ఉంది, కంటైన్స్ అనే ఒక మెథడ్ ఉంది, ఇటరేటర్ అనే ఒక మెథడ్ ఉన్నది. ఓకే, 2 అనే ఒక మెథడ్. సో ఇక్కడ ఏం చేస్తున్నాను అంటే మనకి ఏమైతే రిక్వైర్మెంట్ ఉన్నాయో ఆ రిక్వైర్మెంట్ బేస్ చేసుకొని నేను ఎన్ని మెథడ్ డిఫైన్ చేశాను. బట్ ప్రస్తుతానికి మన ఎగ్జాంపుల్లో నాకు ప్రస్తుతానికి ఒకే మెథడ్ రిక్వైర్మెంట్ ఉండి ఆ ఒక్క మెథడ్నే నేను ఇక్కడ డిఫైన్ చేశాను. ఓకే, కానీ ఇక్కడ ఎన్ని మెథడ్స్ నీకు అవసరం ఉంటాయో అన్ని మెథడ్ మనం డిక్లేర్ చేసుకోవచ్చు.
ఏ మెథడ్ అయినా యూజ్ చేసుకోవచ్చా సార్?
అంటే ఏ మెథడ్ అయినా అంటే బేసిక్గా ఇప్పుడు నువ్వు ఒక మెథడ్ రాసేటప్పుడు ఫస్ట్ దాని పర్పస్ ఏంటో తెలుసుకోవాలి. నేను ఇక్కడ ఈ మెథడ్ ఎందుకు రాస్తున్నాను, సో ఈ మెథడ్ నేను ఎందుకు యూజ్ చేస్తాను, ఫ్యూచర్లో కూడా ఈ మెథడ్ నేను ఎందుకు యూజ్ చేస్తానని ఫస్ట్ నువ్వు ఐడెంటిఫై చేయాలి. ఇక నేను ఈ మెథడ్ ఎందుకు రాశాను, షో అనే మెథడ్ ఎందుకు రాశాను అంటే ఇక్కడ నాకు ఈ రిక్వైర్మెంట్ ఉండే ఐ అండ్ జే వాల్యూస్ని ప్రింట్ చేయాలనే ఒక రిక్వైర్మెంట్ ఉంది కాబట్టి నేను ఈ మెథడ్ని డిఫైన్ చేశాను ఇక్కడ. ఓకే, సో ఇంకొక మెథడ్ రాశాను అనుకో. ఫర్ ఎగ్జాంపుల్ మన కేసులో సమ్మే తీసుకుందాం. ఇక్కడ సమ్ అనే ఒక మెథడ్ నేను డిఫైన్ చేశాను. సో ఈ మెథడ్ పర్పస్ ఏం చేస్తుంది బేసిక్గా ఈ మెథడ్ ఈ ఐ అండ్ జే వాల్యూస్ ఉన్న సమ్ చేస్తుంది ఇక్కడ. ఓకే, ఐ అండ్ జే ఎంత అయితే వాల్యూస్ ఉందో ఆ సమ్ చేసి ఆ సమ్ని ఇక్కడ ప్రింట్ చేస్తుంది. ఈ మెథడ్ డిఫరెంట్ ఆపరేట్ చేస్తుంది. సేమ్ వే ఈ మెథడ్ ఇట్స్ డిఫరెంట్ ఆపరేషన్ ఇస్ డూయింగ్. ఓకే, అంటే ఇక్కడ ఏంటంటే ఏ మెథడ్ అయితే మనం డిఫైన్ చేస్తున్నామో ఫస్ట్ ఆ పర్పస్ ఏందో తెలుసుకోవాలి. నిజంగా ఆ రిక్వైర్మెంట్ ఏందో తెలుసుకున్న తర్వాత ఆ మెథడ్ని డిఫైన్ చేస్తాం. ఫర్ ఎగ్జాంపుల్ ఇంకో క్లాస్ చెప్తాను. ఇక్కడ ఇదొక క్లాస్ ఉంది. ఇక్కడ నువ్వు అబ్జర్వ్ చేస్తే బేసిక్గా చాలా మెథడ్స్ ఉంటాయి మనకి ఇక్కడ. నా ఇదొక కన్స్ట్రక్టర్. ఎందుకు కన్స్ట్రక్టర్ అన్నాను అంటే ఇది నేమ్ ఆఫ్ ద క్లాస్. క్లాస్ నేమ్ ఏంది ఇక్కడ చూస్తే టాప్లో అరే లిస్ట్ అనే క్లాస్ ఉంది. ఓకే, సో క్లాస్ నేమ్ ఇక్కడ కన్స్ట్రక్టర్ నేమ్ ఇస్ మ్యాచింగ్ ఇయర్. సో సేమ్ ఇయర్. సో కన్స్ట్రక్టర్ అండ్ క్లాస్ నేమ్ ఇస్ సేమ్. నా ఇక్కడ చూసే పబ్లిక్ క్లాస్ అరే లిస్ట్ ఇయర్. సో ఇక్కడ ఉన్న ఇది ఇగ్నోర్ చేయి ప్రస్తుతానికి, ఇది ఏంటో అనేది తర్వాత చెప్తాను. బట్ ఇక్కడ ఏంటంటే నువ్వు అబ్జర్వ్ చేస్తే అరే లిస్ట్ అనే ఒక క్లాస్ ఇక్కడ. ఓకే, ఇక్కడ ఒక కన్స్ట్రక్టర్ డిఫైన్ చేశాను. ఇది ఒక కన్స్ట్రక్టర్ అండ్ ఈ కన్స్ట్రక్టర్ ఒక పారామీటర్ ఎక్స్పెక్ట్ చేస్తుంది. ఏం పారామీటర్ ఇది? ఇంటూ పారామీటర్. ఓకే, సేమ్ వే ఇట్ ఈస్ అ డిఫాల్ట్ కన్స్ట్రక్టర్. ఈ కన్స్ట్రక్టర్ ఏం ఎక్స్పెక్ట్ చేయట్లేదు, పారామీటర్స్ ఆర్ ఎంటీ. ఓకే, అండ్ కిందికి వస్తే ఇది ఒక పారామీటర్ కన్స్ట్రక్టర్ ఈజ్ ఎక్స్పెక్టింగ్ డిఫరెంట్ టైప్ ఇయర్. సో ఇక్కడ చూస్తే ఇది ఒక పారామీటరే కానీ ఇక్కడ ఇంటూ ప్రొవైడ్ చేస్తున్నాము. ఇక్కడ కూడా ఒకటే పారామీటర్ కానీ ఇక్కడ ఏంటంటే కలెక్షన్ వీఆర్ ప్రొవైడింగ్. ఓకే, టైప్ ఆఫ్ ద పారామీటర్ ఈస్ డిఫరెంట్. ఓకే, సేమ్ వే ఇప్పుడు చూస్తే ఇది మెథడ్ ఇది. ఓకే, ఇది కన్స్ట్రక్టర్. కన్స్ట్రక్టర్ క్లాస్ నేమ్ ఇస్ మ్యాచింగ్ అండ్ మెథడ్ క్లాస్ నేమ్ ఇస్ నాట్ మ్యాచింగ్. ఇక్కడ చూస్తే ఈ మెథడ్ ఏం చేస్తుంది? ట్రిమ్ టు సైజ్. ఓకే, ఈ ట్రిమ్ టు సైజ్ మెథడ్ ఇస్ పర్ఫార్మ్ లైక్ పర్పస్ ఇస్ డిఫరెంట్ ఇయర్. ఓకే, ఈ ట్రిమ్ టు సైజ్ మెథడ్ పర్పస్ ఇస్ డిఫరెంట్. ఇక్కడ ఏం చేస్తుంది? ఒక వాల్యూని ఇంక్రిమెంట్ చేస్తుంది, ఇక్కడ ఒక కండిషన్ చెక్ చేసుకుంటుంది, దాని తర్వాత కాపీ చేయాలన్నా ఎంటీ ఏదో ఒకటి ఇక్కడ ఆపరేషన్ అయితే చేస్తుంది ఇక్కడ. సో ప్రస్తుతానికి ఇది నీకు అర్థం కాకపోయినా ఇక్కడ చూస్తే ఈ మెథడ్ ఏదో ఒక ఆపరేషన్ చేస్తుంది ఇక్కడ. ఓకే, ఈ మెథడ్ డిఫరెంట్ ఆపరేషన్. సో ఇక్కడ ఇంకొక మెథడ్ ఉంది, ఎన్ష్యూర్ కెపాసిటీ అని ఇంకొక మెథడ్ ఉంది. ఈ మెథడ్ ఒక పారామీటర్ ఎక్స్పెక్ట్ చేస్తుంది. ఓకే, సో ఇది డిఫరెంట్ ఆపరేషన్. అండ్ ఇంటర్నల్గా నువ్వు ఇంకొకటి చూసుకోవచ్చు, గ్రూ అనే ఒక మెథడ్. ఇది కూడా ఒక పారామీటర్ ఎక్స్పెక్ట్ చేస్తుంది. ఓకే, సో ఇఫ్ ఐ విల్ షో యూ దిస్ నౌ, ఈ మెథడ్ బేసిక్గా ఆబ్జెక్ట్ అరే రిటర్న్ చేస్తుంది. ఇదే నేమ్ ఆఫ్ ద మెథడ్. ఇది ఒక పారామీటర్ ఎక్స్పెక్ట్ చేస్తుంది. ఓకే, ఇంటర్నల్గా మనం ఈ ఆపరేషన్ చేస్తుంది ఇది. ఓకే, ఈచ్ మెథడ్ అంటే ఇక్కడ ఎన్ని మెథడ్స్ అయితే డిఫైన్ చేశానో ఒక్కొక్క మెథడ్ పర్పస్ ఈస్ డిఫరెంట్ ఇయర్. ఇక్కడ మనం చూసుకుంటే trim to size method is doing different operation, ensured capacity is doing different operation, and grow method. So grow method and grow method internally, this is the another method. So new capacity, idoka method. Okay, so huge capacity, idoka method. ఇది size అని ఒక మెథడ్. ఓకే, ఈజ్ ఎంటీ అని ఒక మెథడ్. ఇట్లా మనం ఏం చేయాలంటే ఎప్పుడైతే మనం క్లాస్ డిఫైన్ చేస్తామో అప్పుడు ఆ డిఫైన్ చేసేటప్పుడు ఆ మెథడ్ ఎందుకు రాస్తున్నాను, దాని పర్పస్ ఏంది, ఫస్ట్ మనం ఐడెంటిఫై చేసుకోవాలి. ఓకే, ఆ ఐడెంటిఫికేషన్ ఎప్పుడు వస్తుంది అంటే నువ్వు మల్టిపుల్గా ప్రాక్టీస్ చేసినప్పుడు నీకు ఒక అండర్స్టాండింగ్ వస్తుంది, ఒక్కొక్క మెథడ్ ఎలా వర్క్ అవుతుంది, ఏ మెథడ్ రిటర్న్ చేయాలి, ఏ మెథడ్ను రిటర్న్ చేయకుండా ఇంటర్నల్గానే పర్ఫామ్ చేయాలి. సో ఇక్కడ చూస్తే ఈ మెథడ్ ఒక వాల్యూ రిటర్న్ చేస్తుంది. ఓకే, అండ్ ఈ మెథడ్ ఆల్సో ఒక వాల్యూ రిటర్న్ చేస్తుంది, ఎందుకంటే ఇక్కడ ఇంట్ పెట్టాను. అండ్ ఇక్కడ చూస్తే ఈ మెథడ్ ఏం రిటర్న్ చేస్తలేదు. ఓకే, ఎన్ష్యూర్ కెపాసిటీ అనే ఒక మెథడ్ ఉంది, వాయిడ్ మనం ప్రొవైడ్ చేస్తాము. ఈ మెథడ్ ఈస్ నాట్ గోయింగ్ టు రిటర్న్ ఎనీథింగ్. అండ్ ఇక్కడ చూస్తే ఇది రిటర్నింగ్ సంథింగ్, ఆబ్జెక్ట్ అరే ఇట్ ఇస్ రిటర్నింగ్. ఓకే, సేమ్ వే ఇది రిటర్నింగ్ ఇంటూ వాల్యూ. సో ఆఫ్టర్ కంప్లీషన్ ఆఫ్ దిస్ పర్టికులర్ ఆపరేషన్ ఇట్ విల్ రిటర్న్ సమ్ ఇంటూ వాల్యూస్. ఓకే, ఇట్లా ఒక్కొక్క మెథడ్ సమ్ డిఫరెంట్ వాల్యూ రిటర్న్ చేస్తుంది. సో ఇంటూ వాల్యూ కాకుండా, డబుల్ వాల్యూ కాకుండా, ఫ్లోటే కాకుండా ఆబ్జెక్ట్లు కూడా రిటర్న్ చేస్తుంది. మనం ఆ ఎగ్జాంపుల్ కూడా డిస్కస్ చేసాము ఎక్కడ, సంథింగ్ మేబీ ఇన్ ద బాక్స్ క్లాస్ ఐ హోప్, లైక్ ఈక్వల్స్ మెథడ్. somewhere I explained the returning of the object type here. Okay, so first how many times you are going to practice, then only you will understand. So like which method I want to define and what is the purpose of this particular method here. Okay, so ఇది ఇంపార్టెంట్ here. So same way ఇక్కడ ఓన్లీ నేను 2 మెథడ్స్ డిఫైన్ చేశాను నా రిక్వైర్మెంట్ ప్రకారంగా. ఫస్ట్ ఐ అండ్ జే వాల్యూస్ ప్రింట్ చేస్తున్నాను, సెకండ్ వన్ సమ్ మెథడ్ని ప్రింట్ చేస్తున్నాను. అంటే ఆ రెండు వాల్యూస్లో సమ్ ఎంత అవుతుందో ఆ సమ్ని ఇక్కడ ప్రింట్ చేస్తున్నాను. ఓకే, సో ఇది ఇంపార్టెంట్ హియర్. అర్థమైందా?
అవి గుర్తుపెట్టుకుంటే చాలా సార్.
సో ఏవి నువ్వు అనేది అర్థం కాలేదు.
అంటే ఇప్పుడు షో, సమ్ము, ఇంకా చాలా మెథడ్స్ చూపించారు కదా సార్.
ఇవి గుర్తుపెట్టుకోదు. ఇవి నా పర్పస్కి ఇక్కడ ఎగ్జాంపుల్ పర్పస్గా రాశాను. సో నువ్వు ఫస్ట్ ఇక్కడ ఏం అర్థం చేసుకోవాలి అంటే మెథడ్ అంటే ఏంటి, అది ఎలా డిఫైన్ చేయాలి, సో ఎలా వర్క్ అవుతుంది ఇంటర్నల్గా, అది గుర్తుపెట్టుకో. ఈ మెథడ్ ఎలా వర్క్ అవుతుందో అన్నది కాదు ఇక్కడ. ఈ మెథడ్ ఎలా వర్క్ అవుతుందని గుర్తుపెట్టుకుంటే నువ్వు అంటే ఇంకా ఫ్యూచర్లో మెథడ్ రాయలు. సో అక్కడ నువ్వు ఏం చేయాలంటే ఈ మెథడ్ ఇక్కడ మనం డిఫైన్ చేసిన ఈ మెథడ్లు ఒక ఆపరేషన్ చేస్తాయి. ఇక్కడ బాక్స్ క్లాస్లో నేను ఒక మెథడ్ రాశాను, ఈ మెథడ్ ఇది మల్టిప్లికేషన్ చేస్తుంది. ఇక్కడ ఈ మెథడ్ డిఫరెంట్ ఆపరేషన్ చేస్తుంది. ఈ స్క్వేర్ అనే మెథడ్ డిఫరెంట్ ఆపరేషన్ చేస్తుంది. సెట్ వాల్యూస్ అనే మెథడ్ డిఫరెంట్ ఆపరేషన్ చేస్తుంది. సో ఇది కూడా ఒక మెథడ్, గెట్ విత్ మెథడ్. ఇది వాల్యూని రిటర్న్ చేస్తుంది. ఇక్కడ ఇది ఏం చేయట్లేదు, జస్ట్ ఒక వాల్యూని రిటర్న్ చేస్తుంది. సో సేమ్ హైట్ అనే ఒక మెథడ్ రిటర్న్ చేస్తుంది. ఓకే, డెప్త్ అనే మెథడ్ ఇంకొక వాల్యూని రిటర్న్ చేస్తుంది. కానీ ఇక్కడ ఈచ్ మెథడ్ ఇంటర్నల్లీ ఇట్ ఈస్ డూయింగ్ ద డిఫరెంట్ ఆపరేషన్. బట్ మన ఇక్కడ ఏం అర్థం చేసుకోవాలి అంటే మెథడ్ని ఎలా డిఫైన్ చేయాలి, ఏ కేసులో డిఫైన్ చేయాలి, ఎందుకు డిఫైన్ చేయాలి అన్నదే కావాలి ఇక్కడ మెయిన్. ఓకే, నువ్వు ఈ మెథడ్ని గుర్తుపెట్టుకుంటే సో ఈ పర్పస్ వేరు. ఎప్పుడు నువ్వు ఇంకా షోయే రాస్తావు, కానీ రియల్ టైంలో షో అనే మెథడ్ ఎక్కడ మనం యూజ్ చెయ్యం, చాలా రేర్ కేసులో వాడతాము. సో షో మెథడ్ కన్నా లెట్ మీ సీ ఎనీ అదర్ ఎగ్జాంపుల్ ఐఎమ్ హ్యావింగ్. ఇక్కడ చూస్తే నేను ఒక హోమ్ అని ఒక మెథడ్ రాశాను, ఇక్కడ డిఫరెంట్ ఆపరేషన్ చేస్తున్నాను నేను ఇక్కడ. ఓకే, ఇక్కడ సేవ్ కస్టమర్ అని ఒక మెథడ్ రాశాను, కానీ కస్టమర్ని రిటర్న్ చేస్తుంది. ఇక్కడ హోమ్ అనే ఒక మెథడ్ రాశాను, ఇది లిస్ట్ ఆఫ్ కస్టమర్ని రిటర్న్ చేస్తుంది. సో ఇక్కడ చూడు, ఇక్కడ మెథడ్లు ఎలా డిఫైన్ చేశాను, వాటి పర్పస్ ఏందని. ఇక్కడ చూసుకుంటే ఓన్లీ షోని డిఫైన్ చేశాను, ఇక్కడ ఓన్లీ ఒక్క లైనే ప్రింట్ చేస్తున్నాను. కానీ నువ్వు ఇక్కడ చూస్తే ఒక్కొక్క మెథడ్ ఇంటర్నల్గా చాలా ఆపరేషన్ చేస్తుంది. ఈ మెథడ్ బేసిక్గా ఇది ఇంటర్నల్గా ఇది ఒక ఏపీఐని కాల్ చేస్తుంది, వచ్చిన రిజల్ట్ని ఇక్కడ రిటర్న్ చేస్తున్నాను. అండ్ ఇక్కడ లిస్ట్ ఆఫ్ కస్టమర్స్ అంటే మల్టిపుల్ ఆబ్జెక్ట్ రిటర్న్ చేస్తున్నాను. ఓకే, ఇక్కడ సింగిల్ ఆబ్జెక్ట్ను రిటర్న్ చేస్తున్నాను. బట్ ఇంటర్నల్గా ఇక్కడ ఏం జరుగుతుంది, Let me go back to here. Custom service. ఎక్కడ ఉంది ఇది కస్టమ్ సర్వీస్? ఎక్కడ ఉంది? ఇక్కడ చూస్తే మళ్ళీ మెథడ్స్ ఉన్నాయి. ఓకే, సో సేవ్ కస్టమర్ అని ఒకటి ఉంది. ఇంప్లిమెంటేషన్కి వెళ్ళాను నేను. ఇక్కడ చూస్తే చాలా కాల్ చేస్తున్నాను మళ్ళీ. ఇది ఒక మెథడ్, ఇది బేసిక్గా. ఇక్కడ నువ్వు చూడు, పబ్లిక్ వాయిడ్ ఈ మెథడ్ ఏం రిటర్న్ చేస్తలేదు. ఒక పారామీటర్ కస్టమర్ అనే ఒక పారామీటర్ని ఎక్స్పెక్ట్ చేస్తుంది. ఇంటర్నల్గా ఇది డిఫరెంట్ ఆపరేషన్ చేస్తుంది. ఓకే, అండ్ మళ్ళీ ఇక్కడ నేనేం చేస్తున్నాను, ఇంటర్నల్గా ఇది కాల్ అవుతుంది. ఓకే, సో నాకు సోర్స్ కోడ్ లేదు, అందుకే షో అవ్వట్లేదు. బట్ ఇక్కడ నువ్వు అబ్జర్వ్ చేయొచ్చు, ఈ మెథడ్ ఏం ఎక్స్పెక్ట్ చేయట్లేదు, పారామీటర్ అనేది ఏం ఎక్స్పెక్ట్ చేయట్లేదు. బట్ ఎన్ని లైన్స్ ఆఫ్ కోడ్ నేను రాశాను ఇక్కడ. ఓకే, సో బేస్డ్ ఆన్ అవర్ రిక్వైర్మెంట్ వీఆర్ గోయింగ్ టు డిఫైన్ ద మల్టిపుల్ మెథడ్స్. సో ఇక్కడ చూసే సేవ్ కస్టమర్ అనే ఒక మెథడ్, గెట్ ఆల్ కస్టమర్ అనే ఒక మెథడ్, గెట్ కస్టమర్ అనే ఒక మెథడ్, అండ్ డిలీట్ కస్టమర్ అనే ఇంకొక మెథడ్. అంటే ఇక్కడ గెట్ కస్టమర్కి ఏమో లాంగ్ పాస్ చేస్తున్నాను, డిలీట్ కస్టమర్కి ఏమో ఆబ్జెక్టివ్ పాస్ చేస్తున్నాను. ఓకే, గెట్ ఆల్ కస్టమర్ అనే మెథడ్కి నేను ఏం పాస్ చేయట్లేదు. సో సేవ్ కస్టమర్కి ఒక కస్టమర్ ఆబ్జెక్ట్ పాస్ చేస్తున్నాను. అంటే ఇక్కడ ఏం చేస్తున్నాను, బేస్డ్ ఆన్ అంటే ఏదైతే రిక్వైర్మెంట్ ఉందో ఆ రిక్వైర్మెంట్ బేస్ చేసుకొని నేను మెథడ్ క్రియేట్ చేస్తున్నాను, దానికి సంబంధించిన పారామీటర్స్ యాడ్ చేస్తున్నాను. సో ఇక్కడ కరెంట్ ఎగ్జాంపుల్కి ఈ మెథడ్కి మాత్రము మనకు పారామీటర్స్ అవసరం లేదు, ఓన్లీ సింపుల్ మెసేజ్ ప్రింట్ చేస్తున్నాను ఇక్కడ. సో ఇప్పుడు అర్థమైందా మెథడ్ ఎందుకు క్రియేట్ చేయాలి, అది ఇంటర్నల్గా ఎలా వర్క్ అవుతుంది అనేది? Okay, so this is important, the concept we are discussing, something like method overriding here. Now basically why we want to override the methods here. So this is the another important concept here. So basically, as I explained here, the method overriding concept is going to support the runtime polymorphism. So we have a two polymorphism here. First one is a compile time polymorphism. The concept we'll call it as a overloading concept here. And the runtime polymorphism we are going to understand, like we are going to achieve the with help of this particular method overriding concept here. First here, why we want to override here? Basically, so here the general class is going to specify the method, so that will we are going to use for the common purpose. Getting the point? So for example, here only we define the one super class here. Okay, inside the super class I'm defining the method. This method is going to use common for all these particular classes here. Yes, so whatever we are discussing here, each and every class we are going to have an internal link here. Getting the, so whatever the day-to-day session I'm going to discuss here, so you need to practice very well, then only the upcoming concepts you can easily understand here. Otherwise, so you are going to stuck some locations, you cannot understand what I'm trying to explain. So that's the reason. So whatever the recorded session I'm giving here, so try to go through the all the recorded session day to day, so that whatever we are discussing here we can easily understand here. Okay, so back to here, this is the super class I'm defining, and internally I'm trying to define some common functionality. So this particular common functionality I'm defining in the super class, but this super class is going to override into subclass 1, okay, or subclass 2. What happening internally, you can use the common functionality, you can go for the same common functionality. But the problem, whenever you want to specify the specific implementation, for example, here what happening internally, I don't want to use this particular common related functionality which we implemented inside this particular super class. Okay, but what we can do, the same method we can override into this particular subclass here, and we can go for the common logic here. So what is the common logic, basically what we are doing here? So for example, here I'm trying to print the I and j. I and j basically is a common for these two classes. So here we can access the I and j, and here also you can access the I and j. But the problem, I want to provide the specific value. What we did basically, we are introduce one more variable called k variable. So here I want to print only k value. I want to print only k value. So just we are override the method and we are printing the k value. Same way here also we did the same, the k value we are printing, but still you can go for the common functionality. So if I want to go for the common functionality, so comment out this particular method. Again, compiler what it will do, it will try to look up the superclass method and it will print the common functionality here. Okay, but here now you cannot understand what is exactly the common functionality it will do, but in the real time scenarios we are going to define multiple methods as a common. Multiple methods we are going to make as a common. So most of the cases we are going to call it as a util package. Okay, so utility classes we are going to define in the real time. Now what they will do, this utility, the classes we are going to call multiple places here. This utility classes we are going to call multiple locations here. So this is very important information we need to understand here. Getting the point? So this is a way, getting the point? This is a way we are going to write the multiple, the common classes. Okay, but in our current example we could not understand what exactly it is, because it is the simple example we are defining here. We are not going to define much example here. Okay, so now what you understand here, either if you're not interested we can override the same method and we can implement the specific logic. Otherwise we can use the common logic which we are implemented inside the superclass. Okay, so this is the purpose of that, the method overriding concept is introduced here and we are going to override. But the problem, whenever you are trying to override, what happens internally, the superclass method is going to hide here. Okay, the superclass method is going to hide. So this is very important information we need to understand here. Getting the point? So these are all the two important concepts we need to understand whenever we are trying to come up with this particular method overriding concept here.
Sir, why is called compile time and also runtime error for
Yeah,
overloading?
see, basically, compile time, what happens basically, compiler cannot understand what kind of the object we are going to create, because objects are created at runtime only, not the compile time. So this is what we discuss. We'll go to here. If I'm going to open this, so here what we are doing is we are trying to specifying the objects here, but these objects are going to create it at runtime. Getting the point? This is important, not the compile time. So compile time, what we did in the last example, whenever I'm trying to explain the command line example here, we are compiling the code. Again, we are running the code. Whenever we are trying to run the example, then only the objects are going to create it here. But because of this particular IDE, we are not getting the functionality, the compilation code. Basically, this particular IDE, what it will do internally, whenever you are going to modify some changes, automatically it will compile. Getting the way, automatically this compiler will available by default, it will compile all the information here. But from the command line, we don't have a compiler, we need to explicitly compile all the programs here. Okay, so that is the differences we identified here.
Okay.
Okay, so one more, the important example I'm going to discuss here, applying the method overriding concepts here. Okay, so this is also one of the important here line. Now you can see, so this is one of the like the real-time example. So inside this inheritance only, I'm going to write the name of the class, and here what I'm doing is I'm trying to write the name of the class as a figure. Inside this particular name of the class as a figure, now what I'm doing is I'm going to make as a parameters. So I'm trying to make parameters as a private, because we need to achieve the encapsulation here. Okay, so observe private double and here dimension 1, and the same way private double dimension 2. Okay, these are all the two variables. Now what I will do here, I'm going to generate the getters and setters for this particular variable here. So why I want to generate here, because we made as a variable private. So I'm going to the source and I will select this two and click on the generate. So this is some additional functionality we are going to get from this particular IDE. Otherwise, explicitly we need to define this particular method whenever we are trying to implementing the application from the notepad, some edit place, something, the notepad related example. But IDE will give you some advantage So these are all the some advantage we are going to get here. Now finally, I generated the methods here. Now what I'm doing is, I'm going to provide this particular constructor. So the what is the name of the constructor I'm providing? Something like figure. So why I'm trying to providing this constructor? Because the name of the class we define as a same. So double A comma double B. Okay, and here dimension 1 is equals to A and dimension 2 is equals to B. Okay, so this is the way of writing the constructor. And after this, now what I'm doing here, I'm trying to providing one method, something like area method, and this area in the figure class I'm not doing anything. So just I will print this out, and here, so area for whatever the figure class we define here is undefined. Okay, and because the area method is expecting return value. So what is the return value we can provide here? Something like return the default value I'm providing, something like 0.0. Why I'm providing the 0.0? The data type is important. What is the data type we are using? Something like double. For this particular double data type, we should provide 0.0. Okay, this is we identified here. Now, what we are doing here? Because here we are using the constructor, so we don't need to specify the setters here. If you're not using this particular constructor, we can go for this particular setter concept here. Okay, now I'm trying to comment on. Observe carefully. This is the figure class we created here. Now observe, same thing like in the real time also we are going to create as it is here. We'll create based on our requirement constructors, and we'll create the methods here. Okay, so this is all about the figure class I created. Now what I'm doing is, I'm going to extend this particular class with another class here. Okay, the another class basically rectangle. This rectangle is extending from this particular figure class. And here what we are doing is, I'm trying to generate the constructor. Why I'm trying to generate? Because we don't have a default constructor. So I want to generate the parameters constructor. Now I'm trying to generate it. And after generating here, I'm not adding anything, because this particular class, we don't have any specific properties, like we don't have any specific variables here. Now directly what I'm doing here, again, I'm trying to override the method. The same area method I'm overriding here, and here I'm going to print the message here. Getting the print. Inside area for this particular rectangle. Okay, this is the area I'm trying to print here, and I'm trying to return. And here, how I'm trying to return here? So directly we cannot call this particular dimension, because the dimension 1 we made as a private. So what we can do here, I'm going to call get to dimension method. So dimension 1 multiply get to dimension 2. Okay, the superclass method, whatever the superclass method we have, the getters method, I'm trying to use into this particular class. Okay, this is the specific implementation. Basically, the area method is already available inside this particular figure class. Okay, figure basically it is a superclass. Now what I'm doing is, and the same area method I'm trying to again overriding into this particular rectangle class. So this is the specific implementation we provided inside this particular rectangle class. And the same way, what I'm doing is, I'm going to provide the one more example. So this is triangle basically. Okay, this is the triangle example I'm discussing. Now this particular triangle, now what happening internally, again is going to extend from the same class, whatever the figure class we defined here. Whatever the figure class we define. Now I'm trying to generate the two parameters constructor. This is important. Why we are generating it? Because we don't have the default constructor. Okay, and I will copy the specific the area method inside this particular inside this particular triangle. And here, now observe carefully. Observe carefully. So I'm trying to providing the message inside area for this particular triangle. And here, whatever I'm trying to provide, I'm trying to divide here. Getting the point? Now what we need to understand here, I'm trying to load all the dimensions information, and based on this particular dimensions, I'm trying to dividing by 2. So after doing this particular division operation, whatever the result we are going to get, the result, it is written by this particular area method. Okay, this is very important example we are discussing here. Okay, so this is the another example. Now we'll go to this same example here. This is the same, whatever the objective, whatever this particular object we are used here. So otherwise, I will create one more class here. So instead of using all the example inside this, so it is not the good behavior. So figure and rectangle, get in the back, and triangle. And here I'm going to use as a main. So see the shortcuts, how I'm using the naming convention. First one figure, second one rectangle, third one triangle, and main class. And internally, I'm going to figure the F1 is equal to new, whatever the object I'm trying to create here. So this particular object is expecting 2 parameters. So what is the 2 parameters we can provide? 78 dot something like 8 and comma 98.9. Okay, so this is the 2 values. And so rectangle we are creating R1 and new. This is the 2 parameter is expecting something like 45.5 comma 65.6 here. Okay, so this is the one more class, and triangle 1 new triangle, and here 12.2 and 32.3. This is the 3 objects. So same way, what I will do, so whatever we created the dynamic method dispatch here, again we are going to implement same thing. Like now you can see figure something like F2. I'm declaring this F2 is equals to F1. Okay, and F2 dot area, F2 dot area, and finally F2 is equals to something like R1, something like R1. Again F2 dot the same area I'm going to call. Okay, and F2 is equals to T1 and F2 dot again area I'm going to call. So this is important example we are discussing here. So compile time, again it will look up the figure class. Runtime, it will go for the whatever the specific object we created. Now if I'm going to run this example, now observe carefully what happening internally. So area for this particular figure is undefined, and inside the area for the rectangle and triangle. But what is the value? Why the value is not printing here? Getting the point. This is important. Only the inside the whatever the message we provided, only the message is printing. But now I want to provide the value also. What is the value? It is returning. So to print this particular value, now write the sysout statement here. Now you can print this particular sysout statement. Now it will print this. Now you can see these are all the values we are getting. The first one we are getting as a 2984 for this particular rectangle, and the triangle we are getting as a 197. Now here you can see, so we implemented the specific purposes here. Inside the figure class, we provided the common purpose. Now inside the each class, what we did basically, we implemented the specific purposes here. Okay, so this is a way we are going to write the one of the important concept called the method overriding here. Okay, any questions here? Okay, we discussed the multiple example on this particular method overriding concept. This is very important example. So we come up with the multiple, and internally we identified the how this particular objects are going to created, and later we discuss about the super keyboard. Now what we need to understand here, how this particular abstract classes are going to work internally. Okay, so this is basically the abstract classes are going to have a relation between the method overriding concepts here. Okay, this is important here. Basically, now what happening internally? So there are some situations here. We are going to define the super classes information, and the classes will declare the structure of the classes will declare the structure of the particular operations here. Getting the point. So this is important here. Right now, what happening internally? Whenever I'm trying to define any superclass here, the superclass informations are going to hidden whenever you're trying to provide the specific implementation. Even not only this particular method, if I'm trying to providing this particular not only this particular methods, if I'm trying to override this particular dimension values, what happens internally? If I'm trying to write the same information into this particular same class here, this variables also it's going to hidden inside the super class. Getting the point? This variables also it is going to hidden inside this particular super class. But to handle this particular situations here, we are going to work with the abstractions here. What exactly the abstraction will do? Just we are going to create the structure of the classes here. Okay, just we are going to create the structure of the classes here. We are not going to provide the implementation. So this is very important. We need to understand. Okay, and here just we'll define the information here. The information is going to implemented by inside the subclasses here. Whenever the particular classes are going to extended here, so those classes are going to implement those particular whatever we are going to define inside the super classes here. Okay, this is important. We need to understand here. For this purpose, we are going to use the abstractions here. Getting the point? So to define the structure of the given information, like given information is nothing but so if you are going to provide the variable or if you are going to provide the method. Okay, and for these two purposes, what we can do, we can make abstractions here. And those when whatever the information we are going to make as an abstraction, so internally we are going to implement whenever we are going to extend the abstract class here. Okay, whenever we are going to get extended the particular abstractions here. This is very important example here. Now understand here. What I am doing basically, I am going to define the same example here. The simple example here only I am going to provide. So instead of defining this particular area, because basically there is no use here. Okay, the area here we are not defining anything here. So why we need to come up with this particular method body and why need to specify this particular information here. Okay, so to understand this particular figure example, I am going to explain another important example. So let's see. I'm going to create a package first. So abstract is basically it is a keyword. I'm giving capital here because small a is a keyword here. Now inside this particular abstraction, I'm going to create a one class, abstract A class. Okay, this is important. So each and every class I'm starting with the concept here. Abstract A class I'm defining, and now observe carefully. So basically this is the call me method I'm trying to define. So here this call me method I'm not going to provide the body. If I'm going to provide the body, what happening internally? If any class is going to extended with this particular class, getting the point. If any class is going to extended with this particular class here, this method, whatever the method we are defining inside this particular abstract class here, the method is hiding. That we already identified in the earlier example. So again, I don't want to discuss. Now what I'm doing here, this method, I'm not defining anything here. So just I'm making abstract here. Why I'm making this method as an abstract here? Basically, this method I'm not interested to implement at this time here. Getting the point? Whatever the method we are defining, the call me method, I am not interested at this time to implement this particular method. So those method, what we are doing here, we are going to make as a abstract. So here, just we are defining the structure of the operations. Getting the point? This is important. So just I'm defining the structure. So it does not contain the implementation here. Just we are defining this. It is nothing but we are defining the method here. Okay, defining this particular method here. Now, what we need to understand, whenever if you are trying to define any method, whenever if you are trying to define any method with a declaration here, so the method should come up with a abstract here, and whenever we are making any method as an abstract, the class should also make as an abstract here. Okay, the class also we need to make abstract here. This is very important here. Any method if you are making as an abstract, the class we need to make as an abstract. Why we need to make as an abstract here? Because this particular class, it is not a fully implemented here. Getting the point? This particular class is having some partial implementation. So why this particular class is having the partial implementation? So some of the method, like whatever the method we are going to use in the subclasses here, so those methods I am not going to implement here. Okay, I am not going to implement those methods directly. I'm declaring the method here. So it's nothing but just I'm giving the structure of this particular method, and this particular method is going to implement it inside this particular subclasses here. So what are all the classes? Those classes are extended with this particular abstract class A. So all the classes are going to implement this particular method. Now observe carefully. So here we don't have a concept to call method hiding here. Getting the point? Here we don't have a concept to call method hiding. Basically, compiler now it will look up the implementation class. Where it will go the implementation class? Any class if it is going to implement, like any class if it is going to extend this class, the class should be implement this. So for example, now I'm trying to provide one more method, call me to method I'm defining, and this particular call me to method, now what I'm doing is I'm trying to providing the information here. So this is basically concrete method. Okay, this method basically we'll call it as a concrete method, and this method having the body. This method having the body here. Okay, it's open the line number 5 and we close the line number 7. But to compare with the line number 4 method, so this method does not contain the body. So just we are declaring the method. This method is going to implemented by subclasses, and this method is the common method I'm defining here. Again, if you are trying to do the same method inside the subclass, and this method also be hidden. This method also be hidden here. But what I'm doing here, along with the abstract method, along with this particular abstract method, we can add normal methods as well inside this particular abstract class. So this is the purpose I'm trying to explaining here. Okay, now understand here. Now what I'm doing here, I'm going to extend this particular abstract to A class. Whenever I'm trying to extend with this particular abstract to B, this particular class is going to extend it. This particular class is going to extend from the abstract here. Whenever I'm trying to extend here, now observe carefully, we are getting an error. So why we are getting an error here? Getting the point. Whenever I'm trying to extend this particular class, I'm getting an error here. So if I'm going to see this particular error, now what is the error we are getting? Here is showing implement the method. So what is the method is expecting to implement? Something like call me. Now if you go to this particular abstract class here we define this particular method, and the method we are implementing inside this particular call me method, like inside this particular abstract B class. Getting the point? This is important here. Inside this particular abstract B class, what we are doing is we are trying to implement here. But where we define this particular method, the method we define inside this particular abstract class here. So now observe, whenever I'm trying to create an object of this particular class, compile time, and runtime. Because compile time, the method is available here. Compile time, we made this particular method is available, but here the method is not yet implemented. Just we declare the method. Getting the point? And here there is no concept called method hiding here. Whenever we are trying to providing the abstract method, and here we are not going to achieve the method hiding concept, but here we are achieving the method overriding. Getting the point? The same method we declare in the super class, again we are trying to override into this particular class. But here the functionality, the super class method cannot have a body. Only the subclasses method is going to have the body. Okay, so this is the very important example we are discussing, this particular abstraction. And this particular class will contain only structure here, like how we are going to write the application, the structure information we are going to write. For example, so here not only this particular call me method, if in case any method it is required, in case any method it is going to require, so those methods also we can write like this, the like method declaration, and the same method we are going to use inside the implementation class here. Okay, now this is the abstraction B I'm trying to define, and here you can write here what is the method you want to write here. So just for understanding, I'm printing the statements here. Okay, so this is basically this is the implementation. Okay, not this is basically abstract B class implemented the call me method. Okay, so this is the simple message I want to provide. And finally, what I'm doing here, I'm trying to create a object here. So now AB abstract class A and B. So something like main. Okay, the main class I'm declaring here, and inside this particular main class I'm going to create object. So observe carefully, abstract A is equals to new abstract A. So this is I'm trying to create an object, and another one abstract B is equals to new abstract B. So observe carefully why I'm getting an error, the line number 6 here. Why I'm not getting any error, the line number 7 here. So what is the differences we need to understand? Basically here, what we need to understand here, we cannot create an object of the particular abstract classes. Why we cannot create an object of this particular abstract classes here? This is important here, because here this particular class is not fully implemented here. Getting the point? The abstraction classes basically we are going to use to declare the structure of the program, whatever we are going to use in future. Getting the point? So just we are going to create the structure information, and the structure is going to implemented by in which class here? The subclasses here. What is the subclass we are having right now? Abstraction B. Abstraction B basically it is a subclass, and this particular class it is fully implemented here. So this particular class does not contain any abstraction information. So because of that, we can create an object like this. Okay, we can create an object like this. Now finally, what I'm doing is b dot call me method, and the same way b dot call me to method also I'm able to call. Getting the point? B dot call me and b dot call me to methods I'm calling. Now what you understand basically here? What you understand? One method, the common method we are able to use from the subclass, and whatever the method we declare in the abstract class, the method we implemented inside the subclasses, and the subclass method is calling here. Okay, so this is the basic example we discussed regarding this particular abstraction here. Any questions? Okay, so we'll continue the same continuation of this particular abstraction. Okay, the same continuation example we are going to continue evening, and we'll see. So we are trying to identify the lot of example with the help of this particular abstraction. So once we identify this particular abstraction, we'll try to continue like this is the continuation of this particular inheritance here. Okay, so we'll try to continue the example evening here.